The standard test method for density, relative density, or specific gravity and absorption of fine aggregate. Scope: this test method covers the determinations of average density of quantity of fine aggregate particles, not including the volume of voids between the particles, the relative density, specific gravity, and the absorption of the fine aggregate. Significance and use: relative density or specific gravity is the characteristics generally used for calculations of the volume occupied by the aggregate in various mixtures containing aggregate, including Portland cement, concrete, bituminous concrete, and other mixtures that are proportions or analyzed on an absolute volume basis. The apparatus are weighing scales, picnometer, fine aggregates, oven, water bucket, lead chanteler flask, mold, and the tamper.
Procedure: drying the test specimen. Place the test specimen in a suitable pan or vessel and dry it in an oven at 110 degrees until it reaches a constant mass. After drying, allow the specimen to cool to room temperature. Before proceeding with the main experiment, let us first perform the provisional cone test. Place the cone mold on an iron plate, and then fill the mold approximately halfway with fine aggregate. Lightly tamp the material with about 10 drops. Continue filling the mold with additional fine aggregate, tamping lightly as needed until the mold is full. After that, lightly compact the filled mold by allowing it to drop freely 25 times from a height of approximately 5 mm above the surface of the fine aggregate. Carefully lift the mold. If the fine aggregate retains its shape and does not collapse, it is too wet. But if the aggregate collapses completely, it is too dry. Adjust the moisture content as necessary by drying or adding water. The sample should achieve a saturated surface dry or SSD condition.
Gravimetric procedure using a picnometer. This experiment uses the gravimetric procedure or picnometer method. First, fill the picnometer with water up to the calibration mark. Record this mass as B. Next, pour out approximately half of the water. Then introduce 500 grams of the SSD fine aggregate into the picnometer. Then, add additional water until the level is about 1 inch below the neck. Manually roll, invert, and agitate the picnometer to eliminate all visible air bubbles. Fill the picnometer to its calibrated capacity, then adjust the temperature of the picnometer and its contents to 23 degrees Celsius by partial immersion in a water bath. Record the mass of the filled picnometer as C. Lastly, remove the fine aggregate, dry it in an oven at 110 degrees Celsius to a constant mass. Allow it to cool at room temperature for 1 hour and record the final dry mass as A.
Calculation. So for the bulk specific gravity oven dried, the formula is A over B plus S minus C. For the SSD bulk specific gravity, S over B plus S minus C. For the apparent specific gravity, A over B plus A minus C. For the absorption rate, S minus A over A, and then multiply it by 100. Data. So here is the data that we have accumulated throughout the experiment. For letter A, which stands for mass of oven-dry aggregates in air. Letter B, mass of pycnometer filled with water at bottleneck. Letter C, mass of pycnometer with aggregates filled with water at bottleneck. Letter S, mass of saturated surface dry aggregates. For letter A, we got 488.96 gram as the value. For letter B, 1240.6 grams. For letter C, 1549.2 grams. And for letter S, 500 grams. Okay, so here are the values that we have formulated. For bulk specific gravity OD, 2.55. For bulk specific gravity SSD, 2.61. For apparent relative density, 2.71. For absorption, 2.26. So for the conclusion, based on the experimental data, the calculated bulk specific gravity of the aggregate is 2.55, the bulk specific gravity is 2.61, and the apparent specific gravity is 2.71. The absorption water of the aggregate is determined to be 2.6%. Comparing these results to the standard specification provided, the bulk specific gravity values and the apparent specific gravity falls within the acceptable limits. However, the water absorption of 2.6% slightly exceeds the maximum specified limit of 2.5%. This indicates that the aggregate absorbs a slightly higher amount of water than the standard allows, which could potentially affect the properties of concrete mixtures made with this aggregate.